Hello, and welcome to Becker Breaks It Down. In this episode, we look at proportionality theorems, specifically the Triangle Proportionality Theorem. Now, you've seen this image before, right? Okay. So, like the two triangles in that diagram, QRS and TRU, we know that they would be similar to each other because the angle-angle similarity postulate. Okay. But let's talk a little bit more about those parallel sides because there's another relationship here that we haven't spoken of. Okay, and it says if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. Okay, so TU is that line that's parallel to one side of the triangle, so QS. Okay, so we have this like parallel relationship here. And it's saying that that line has divided the two sides of our triangle proportionally. So we've got the one side, the QR side. That has been split into two smaller segments. You've got QT and you have TR, okay? And so notice they wrote a ratio, RT over TQ, okay? And then the other side of our triangle, we have side SR, and SR has been divided into two segments. You've got SU and you have UR, and those two segments form the other ratio, okay? Also notice the corresponding relationship, like RT and RU, like are both like occupying like corresponding positions of the triangle. Okay, same with QT and SU. And so, like, I guess to simply put it, like, if I orient it like this, okay, you've got your left side, you've got your right side, you've got your top pieces, and you have your bottom pieces. So, like, we can write a proportion, just like this one, where you basically have the left side top over bottom, like those are your two ratios, okay? And then the other ratios that you could totally use here, and these are the ones we've used, is where we went like part over whole. So we can use part of a side and we can use the whole side. And that's what we were using earlier when we were looking at these as similar triangles and not as triangle proportionality with that parallel line, okay? Just make sure everything like matches up and corresponds, okay? So like in this example here, they wrote 10 over x equals 6 over 15, okay? So you got the 10 over x is coming from the left side of this triangle. They wrote it bottom over top, okay? And then 6 over 15 is coming from the right side of the triangle, bottom over top. Cross multiply, divide, you get x is 25, okay? So take a look at problem 2 here. What's a possible proportion I can create for problem 2? Yeah, so I can talk about the left side of this triangle, and I could be like 4 over x minus 6. And I can say that this is equal to the ratio formed by the right side of my triangle, so 2 over 1. And I'm allowed to do this because I do have that parallel relationship. And then from here, I would just cross multiply and divide. So I get x is 8. So how can we set up number 3? Okay. Yeah, I mean, I can figure out like what is that bottom piece. Or, as I was mentioning earlier, because you do have similar triangles here, you can write a ratio where maybe you do like, since you were given the whole side here, maybe you should ask yourself like, what's the whole side over here? And so the whole side over there, 30 plus 18 is 48. So then I can create a proportion where maybe I do part over whole, you know? So if I'm talking about like the left side of this triangle, I could use like 18 over 48 for part over whole. And then on the right side, I could do 21 over 4x plus 8 part over whole. So I can do that in number 3, or I can figure out like what is the bottom right side and do the top over bottom ratio. But I think part over whole is easier. Okay, I end up getting the x is 12. But that's your triangle proportionality theorem. Okay, so if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the two sides proportionally. And that is how Becker breaks it down.